Hello VEX students! Welcome to our first VEX educational tutorial. My name is Andrew Schreck and I am the team captain of Central Hardin Robotics Team 6135W. Today we will begin our first of many VEX educational videos that are designed to help you, the robotics teams of the world, understand the basic and more advanced concepts in the VEX Robotics competition. We were inspired to begin this series because of all of the amazing tutorial videos out in the VEX community today. Through our years in VEX Robotics, we have watched countless tutorial videos to help understand some concepts in the VEX Robotics competition that we were unable to decipher ourselves. We believe it was amazing that people had set aside their own time to make these tutorials available to anyone in need. Today, we are starting our own VEX educational series to give back to the VEX community for all that they have given us. Let's get on to the first lesson. Today, our video is all about the VEX Sonar. The VEX Robotics Sonar is a digital sensor that looks like a red rectangle with two circles in the middle that bear a resemblance to a small speaker. These circles actually shoot out a high-frequency sound pulse outwards that comes back, and then the sonar records how much time it took. But what does this mean? How can we visualize it? Let's think about a runner in a race. When the runner is given the command to start, he shoots off at a constant speed. Immediately when he shoots off, someone starts a stopwatch. When the runner reaches the wall in front of him, he will turn around from the opposite of the angle that he hits the wall. Then, he will travel back to the starting line at the same constant speed as before. When he reaches the starting line again, you stop the stopwatch. Then, you take the time he took to travel the distance and convert it into how far he traveled at a constant speed in that time. All of that is done by the sonar itself. The only thing you have to do is tell the sonar how far you want to be in front of that wall. Let's take a look at the program. As you can see, we use the while loop to tell the robot what to do until the sonar gets to the correct value. The program reads, "While the sonar is more than 8 inches away from the nearest obstacle, set the motor values to go forwards. Then, when the sonar is 8 inches away from the obstacle, it will exit the curly brackets and move on to the next step in the program." Let's take a look of how this would be used in a full program. As you can see here, the sonar is the first line of code that provides movement. We use the sonar here to tell the robot to move forward until it is no longer more than 8 inches in front of the obstacle in front of it. Next, we are going to hop over to another way to use the sonar. The other way to use the sonar is to use the until command. There are two commands, until sonar less than and until sonar greater than. The commands will run whatever is above them until the sonar value is met, and then they will move on to the next lines of program. You can find these as a template by going to the top, Window, Menu Level, Super User, and clicking it, which will open this drop-down page on the left side of your screen. Then you will go to the natural language, until, and you can find them in the bottom as until sonar greater than and until sonar less than. You can click and drag them over to your program where you want them to be used. Then the only thing you have to do is replace the word distance with how many inches, centimeters, millimeters, or the raw data that comes out of the sonar that you want to be away from the object in front of you. Then in the sensor port, write down what you called your sonar or the port that it is in. To change the data, as we are using inches, that you want to record, you can go up to the Motor and Sensor Setup, VEX Cortex Digital Sensors, Sonar, click the drop-down box, and then you can find them as centimeters, millimeters, inches, and then the raw data. After you click OK, then your Cortex will list them in the value and the units that you wanted them. Note, the sonar is not as effective when bouncing off of a diagonal surface. Because the sonar relies on the frequency bouncing directly back, when the frequency hits a diagonal surface, the frequency bounces off at an angle opposite of the angle it hits the surface. If this angle at which the frequency hits the wall is 30 degrees, then the reflected angle will be negative 30 degrees. To relate this to a graph, if you have a line coming right back to the origin, since this is the second quadrant, I would be negative 50 degrees. R would be positive degrees. It is reflected across the y-axis, which is also the line of symmetry, and it will continue outwards. The same thing at 80 degrees, negative 80, 80, negative 90, 90. However, if you go down at 180 degrees, if you were to reflect that, it would just go straight back up because the line's slope is undefined. And that is why it is the way that we would like to record, because if it goes straight down and it comes straight back, you don't have to deal with it bouncing off of other surfaces. When the sonar bounces off of other surfaces, it gives the sonar the illusion that it is farther away from the object than it actually is, which could cause an error in your program, which could add up with time. This is the conclusion of our sonar tutorial. We hope this tutorial helped you get acquainted with your VEX sonar. If you have any more questions, feel free to post in the comments section. If you liked the video, please let us know in the comments below, and subscribe to the Central Hardin Robotics YouTube channel for updates on our progress throughout the season, and receive notifications when we post a new VEX educational video. Before we go, we want to issue a huge thanks to the VEX Robotics community for providing teams around the world with your knowledge of the VEX Robotics competition. It means so much to be able to learn a topic directly from the robotics teams that practice it every day. Stay tuned for the next VEX educational video coming next Tuesday.